Welcome back everybody for part 2 of the 7.2 notes and these normal distribution examples. We have just seen some problems where you're asked to find the probability to get a z-score that's less than something or maybe it's more than something. So we're finding these areas under the curve. You're finding the area to the left, you're finding the area to the right, whatever the case may be. Well, sometimes you actually know which probability you're looking for. You already know the probability, you already know the area, for example, underneath the normal distribution to the left or right of some value. And you want to figure out which z-score has that area to the left of it or that area to the right of it. For that, we're going to use, instead of the normal distribution function, instead of going to that normal CDF, we're going to go to inverse normal, because if you remember from college algebra how inverse functions work, they do the opposite thing of the normal function. So normal CDF, you plug in z-scores and it tells you the area. For inverse normal, you plug in the area and it tells you the z-score. It's very nice. But anyway, we're still talking about the standard normal distribution, so we still got mean of 0, standard deviation of 1. Let's see what we should do here. We're looking to find the z-score so that the area under the curve to the left of that z-score is 0.0262. So it's some pretty small area. What do you guys think? If we just had to guess, maybe it's this z-score, because it got some little area over here that's like 0.02. Seems reasonable. Why don't we find out what z-score this is? What number goes here? So what we will do is we will go to the distors again. We want to use this time number 3, which is the inverse normal. The area we're looking for is 0.0262. We got the mean, we got the standard deviation, and we want that tail to be on the left side. The area is to the left. So we will just keep that one. So that z-score that goes here is negative. And remember, we will round to 2 decimal places for this one. So it's a negative 1.94. So that was a big success. What about the z-score so that the area under the curve to the left is 0.9931? Wow, so it's almost the whole thing. So that z-score, we're looking for something pretty large, maybe over here, because we want 99% of the area to be on the left side. So we're wanting all of this area to be 0.99. Well, same deal. We go to inverse normal. This time the area that we're looking for is 0.9931. We're using also the tail on the left. So let's see that one. That z-score that we're looking for is going to be 2. We're rounding to 2 decimal places, of course, 46. So far, so good. What about this one? Do you guys remember this symbol? P70. What is this? It must be the 70th percentile, right? Well, if you remember the 70th percentile, it's such a value that 70% of the data should be less than that. So in other words, we want the area to the left of that value to be 0.7, which is 70%. We want this all over here to be 0.7. So we will go to our distribution menu, inverse normal. We want the tail on the left to have an area of 0.7, or else 0.70 if you like. It's the same number. And it's on the left tail. Let's keep hitting enter. That z-score, I drew it kind of far to the right, but It's not too big of a z-score. It's just 0.52 because we're rounding only to 2 decimal places. So that's a nice problem. What about if we've got tails on the right side this time? We've been dealing with tails to the left. Now we got tails to the right. Luckily, since we're using a TI-84, it's pretty easy to do this one. It's not so nice with a TI-83. But in this case, since we get to choose the tail being on the right, here we want the z-score so that the tail on the right is 0.43. You notice that one is a little bit less than half. So it's going to be, the tail on the right should be a little bit less than half. So let's call this one the mean is in the middle here. We'll be a little bit to the left of the mean, probably not very much. Maybe we'll be there. And then this area is supposed to be the 0.4325. So let's go back to inverse normal. Let's find this area to be 0.4325. We're still dealing with standard one. This time the tail is on the right, so we'll just choose that one. And then, yep, see, it's pretty small z-score. It's just 0.17 standard deviations to the right of the mean. So that z is going to be 0.17. And then this time, we will have the tail on the right to be 0.9713. So that's a really big tail. That's almost the whole area. Again, we've already had that kind of a situation before on the left side. So we want all of this area to be 97% of the area. So why don't we go to inverse normal so that we can find the z-score. The area is 0.971. Oops. 13. And that tail is on the right. And the z-score, it's almost 2 standard deviations less than the mean, but not quite, because it is only negative 1.90. Standard deviations less than the mean. And then, last but not least, what about if the area is in between two values? That's going to be a nice one. So here we're looking for the z-score that separates the middle 70% of the area under the standard normal curve from the area in the tails. So it's the middle 70%. If you remember the empirical rule, it must be, I think I'm a little bit too wide right here, it must be around 1 standard deviation, right? Because that would be 68%. So we're thinking it's going to be probably a little bit more than 1. But why don't we find out, because we can ask the calculator by going to inverse normal, which is number 3. We want the area to be 0.70. This time the tail, we're going to pick center. We want it in between. And this is going to pick the perfectly symmetrical one, so that the tail on the left and right are the same size. Let's find it. It's going to be in between the z-score here. I think that we're basically looking at plus or minus 1.0. Oh no, we don't want 3. We want to round it up to 0.04 because of this one. And if you think about it, this would also, this little tail on the left, can you tell how big it should be? If the middle is 70, then that means there's 30% left over, so half of it should be here, so it should be 15% there. I feel like calculating it another way just for fun by finding out what z-score has a tail of 15% to the left. And it better give us the same thing. Wow. It does. So we'll go on to part G right now. Looking to find the z-score that separates the middle 20% of the area under the standard normal curve from the area in the tails. So we don't have a nice picture anymore, but we want only the middle 20%. So it's going to be kind of this little chunky block in the middle. So we want to find the middle part. So we need to do our inverse normal. I think we're getting the hang of it now. We want the tail in the center, and that's going to be kind of wondering the format that is most appropriate for this one, but I like this little plus or minus guy. Plus or minus 1/4 of a standard deviation on either side. So good job on these, but there's more to come.